In this section, we're supposed to solve this triangle using the law of sines and a scale drawing. We didn't do scale drawings in our class, so I'm just going to use the law of sines. And there's two triangles, complete them both. So we're given a triangle. I'm going to start with some straight lines and draw some triangle. Let's see, A, B, and C. So we're told that this is 60 degrees. A is 15 inches. C is 10 radical 3. And you can see my scale is definitely wrong because C is longer than B. So here we have a side-side angle situation. So that gives us to these steps. So the first step to solve this is to use the law of sines to solve for a second angle. So I have angle A and I have side C. So I'm going to try to find angle C. Can't look for angle B since I don't have side B. So in my sine law of sines ratio, I will have two variables for B. So I'm going to use A to find C, and that gives me sine of 60 degrees over 15 equals sine of C over 10 radical 3. When I cross multiply, I get 10 radical 3 times sine of 60 equal to 15 times sine of C. Sine of 60 is equal to radical 3 over 2. So I'll get some cancellation here. My radical, oh no, I'm sorry. They won't cancel because they're next to each other. They will multiply and become a 3. So I get 10 times 3. Radical 3 times radical 3 is 3. So 3 times 10 gives me 30 over 2, which equals 15 sine over C, which is equal to 15. So when I divide both sides by 15, I end up with sine of C equal to 1, which tells me that C equals a sine, so that's the sine inverse of 1. And think about, when is sine equal to 1? When is that y value equal to 1? Is here. That's at 90 degrees. So C must be 90 degrees. Okay, so let's make my little triangle solution box. So I have A is 60 degrees, B is still unknown, C is 90 degrees, side A is 15 inches, side B still unknown, and side C 10 radical 3 inches. So to get those B's, I can't use the law of sines directly because I'll get, they're in the same proportion, so I'll get two variables. So I need to use, so that brings us to, I'm sorry. So I actually kind of skipped a step here. So going to step 1, I find I'm in this situation where I have a perfect 90-degree angle, so I have exactly one solution. And that brings us to, well, I guess to step 4, and I should have written that in those steps. So go to step 4. So we use the triangle sum to find that third degree. So 180 degrees, so that's going to be B equals 180 minus 90 minus 60, which is 30. So I get 30 degrees there. So to get b, then I go to step 5, use the law of sines again to get that last side. So I can do, let's do sine of b is to b as sine let's do c is to c. So sine of b, that's 30 degrees over b, that's what we're going to solve for. Sine of c, which is 90 degrees, all over c, which is 10 radical 3. I'm going to cross multiply first. I could have substituted in simplified, since these are special angles from my unit circle, or cross multiplied first. It doesn't matter. And then I know sine of 30 is 1/2 of 10 radical 3. And oh, you know what I should do? Sorry, is isolate the b. I'm going to divide both sides by 90 and then simplify. So I get 10 radical 3 minus sine of 30, I'm sorry, times sine of 30, which is 1/2, all divided by, sine of 90 degrees, which is 1. So that gives me 5 radical 3.